focus for a few minutes on the mineral part of soil, on the part that comes from rocks. Then we'll get into the living stuff and what it does. So one component, one way we think of the mineral parts of soil is sand. Okay, so here's a grain of sand blown up to this big. And the deal with sand is that it is essentially just really broken up rock. You don't even have to know that much about geology, just a little bit about geology. You can look at a grain of sand through a hand lens and say, oh, that's a granitic sand. That's a basalt sand. That's from limestone or something like that. You can really tell exactly what parent rock it came from. It has not been weathered or transformed. It just looks like little tiny pieces of the parent rock that it came from, whatever that was. Then the next category is silt. And silt is rock that's been broken up a little bit finer for one reason or another. And so here is a grain of silt in comparison to a grain of sand. It's about 10% the size of sand. We all know roughly how big sand is. I think we've all got a feel for that. Silt is just rock that's been ground up to smaller pieces, like that big. And silt also is very much just like the parent rock. If you had a microscope and looked at a little piece of silt and you knew a little bit about geology, you could say, oh, that's from granite, that's from basalt. You would really know. Then the third form is clay. And clay, if it was held up to a piece of grain of sand blown up to this big, clay would be about that big, a clay particle. It's really small. And clay is not like the parent rock. Clay actually is rock that has been weathered and transformed and chemically altered to where you need to be a clay chemist to really identify clays. When I read soil textbooks, which I used to do a lot of when I had all these soil problems, the clay chemistry chapter would be the chapter that I would skip or would like leaf through and get totally baffled by. Clay chemistry is very complex and is kind of a specialized field. But clay is pretty cool stuff, even though a lot of people with clay soils don't like having a clay soil because they're sticky and heavy and gumbo and then they dry out into concrete when they are dry. But clay is actually a really useful thing to have in your soil if you can manage it properly. If you were to take one of these particles of clay and blow it up to where you could actually see it, they often look like little plates, they're often flat little like sheets of paper or plates, and they can stack up like that. Like the reason clay behaves the way it does, the reason that it gets so sticky and gooey and then turns rock hard when it dries, is you can think of it as like sheets of paper. These could be individual pieces of little flakes of clay. So when this gets wet, the pieces, it's like newspaper like this, the pieces will slide past one another and get kind of gooey, the way this would be when it's wet. That's what's happening with clay. The pieces sort of stick together through surface tension and they slide back and forth against one another, so they make this really gooey, slippery mess. And then if I were to wet this and then dry it in the sun, it would turn into paper mache, essentially, right? It would dry all crunchy and hard. And that's what's happening with clay as well. When it dries, the sheets all stick together, it turns really hard. So that's what's going on out in clay soils, why they are so slick when they're wet and so hard when they're dry, is because there's lots of edge on clay, lots of surface area in these clay particles. Unlike a chunk of sand where it's mostly round, doesn't stick together very well, just the way you can hold a wet ball of sand and then when you release your hand it just falls apart. Clay will stick together because all this edge is making it really, really sticky. And clay also has a lot of little sticky atoms sticking out from it that have charges on them that bind to other minerals. So clay is really good at storing minerals. It's one of the things that it does well is it stores nutrients. Calcium will stick to it, magnesium will stick to it, certain kinds of nitrogen will stick to it, so it actually can act as a savings bank for other nutrients. Silt and sand don't act as good nutrient reservoirs. Like anyone who does have a very sandy soil, You keep having to add organic matter or other things to it to keep it fertile often. They're not weathered enough to, they're kind of, all their atoms are still stuck to one another rather than kind of weathered loose. Just the way sandy soil doesn't hold water very well, but clay really does. Clay soils take a long time to dry out. It's the same sort of thing. The clay soils are binding water and holding them in between the various little pieces. And with sandy and silty soils, the water just kind of runs through. Soil scientists for a long time would name soils based on their sand, silt, and clay content. And they drew this graph. Like most of us are used to graphs with two axes like that, an X and a Y axis. When we've got sand, silt, and clay, soil scientists came up with a cool three-axis graph that they call the soil texture chart or texture classification chart, or you can Google all these things. You will get a graph that is actually a triangle, and this axis is the clay axis going from 0 to 100% clay. So it's got a set of tick marks, so pretend I'm drawing 10, I don't know how many I'm drawing, but set of tick marks like that. So if we have a soil that is 30% clay, this would be the roughly 30% axis going across, 10, 20, 30%. Then this axis is the silt axis, going from 0% silt to 100% silt. And the tick marks here are made diagonally. So a 30% silt soil would show up on this graph like that. This is the 30% tick mark. Here's the 30% clay tick mark. And then this is the sand axis. Sand. Going from 0% sand to 100% sand. And the tick marks are diagonally this way. So here's 30% sand. So sand, silt, and clay, yeah, sandy soils, silty clays, all that sort of thing. This fellow back here mentioned he has a sandy loam. So I always wondered, okay, I know what sand is, I know what silt is, I know what clay is. What is loam? What do they mean when they say loam? It turns out loam, besides being an old English word, means a soil that is a perfect blend of sand, silt, and clay. It's got roughly equal amounts of each, roughly. And that makes for a really good soil. It's got all the qualities of sand, all the qualities of silt, and qualities of clay as well. So if you've got a soil that is a blend of all three, sand, silt, and clay, you'd call that a loam. And this is kind of this area in here, except that clay is so powerful. Clay can overwhelm a soil. A soil with even 10% clay or 20% clay is going to be like dominated by clay. Clay is a very powerful element. So a loam is actually a soil with kind of less clay in it. It might be 20% clay and 40% sand and 40% silt. A little clay goes a long way in a soil. And this is why when people say, if you have a heavy clay soil, folks used to say, just add sand to lighten your heavy clay soil, right? Well, the deal is if you've got a clay soil that is 2 feet deep, 3 feet deep, 6 feet deep, whatever, how much sand do you think you have to add to actually change the soil? An equal amount of sand. So if you've got 2 feet of clay, you need to put 2 feet of sand on it to actually change it. Ain't gonna work. And besides, what happens when you mix sand and clay and a little organic matter and then bake it in the sun? That makes adobe, right? So don't add sand to your soil to lighten it. Instead, add organic matter. Organic matter is what will change the quality of a clay soil or a silty soil or a sandy soil. Organic matter is like almost the answer to everything. So now that we know that, we can stop. You know all you need to know about soil. Just add organic matter. We're done. We can move on.